properties and how to apply them using your calculator in mathematics, right? So let's see the way forward. Great, right? So indices, it comes from the word index, which means what? Power exponent. So I can say 2 index 3, this one. 2 index 3 or 2 power 3. This is what it means. Raised to the power or exponent 3. 2 exponent 3. It means the base is multiplying itself how many times? 3 times. So if you see 5 power 2 or 5 exponent 2 means 5 multiplies itself twice. So the power will determine the number of times. I get me? So another word for indices or another description for indices is what? Powers of numbers. Powers of numbers. So we are going to look at powers of numbers. I get me? So this is what they mean. If you write it this way, it's the same as that. So take note of that. Let's move on now. So let's look at the operations of the powers of numbers or indices. They go with laws. They go with what? Laws. And all the laws make sense, which you know already. So the first one, multiplication of equal bases add their powers. This is coming from algebra. You recall algebra? So if you have not watched algebra, watch it and you know why we are behaving this way. But let me give you a brief idea. So you see, multiplication, when you see be fruitful and multiply, what is happening now? We are increasing by the same quantity. I get me? So your parents are multiplying, increasing in the same quantity, adding more human beings, right? So when it's about multiplication, what should come to your mind is addition of their powers. So multiplication of equal bases, what do you do? Add their powers. So the laws work if the bases are the same or if the powers are the same. As you go along to equation, you see exponential equations. So that's all. So you can see, you write the base singular, you simplify it, add the powers. So example in numbers is like 2 power 2 times 2 power 2 means 2 power 4. Why? It was what? 2 plus 2, producing the 2 power 4. How we get the picture? So simple. Now division. What comes to your mind? Division brings about what? Reduction. When I have 20 oranges I shared between this, the quantity reduces from what? 5 each. You get 5 fours. This is what happens. Or 4 fives. 4 of them. 5, 5, 5, 5. So it reduces. So it brings about reduction. Division brings about reduction. Therefore, when dividing equal powers or the same basis, what do you do? We are dividing the same basis. What do you do? Subtract their powers. So you can see from the division, subtract the power. So this is the second law. Third law, bracket means what? Multiplication. So you know already. So when there's a bracket and there's a power inside and the one outside the bracket, they multiply. So multiply them. So m times m is n is what? Mn. So you can see from here, these two will multiply that because they are both powers. You get a picture? It's not a base multiplying power. Power times power. Base times base. Now the next one is when you have a root, right? Is equal to reciprocal of the what? The root sign. I know that this is 2. This is root 2, which is not normally written. That means a certain number multiply itself twice. That's what it means by that. So here was 2. So when you bring it here, we cancel 1 over 2. Because every term or every number is over what? 1. So the 1 goes up, the 2 comes down. That's what you do. Do you understand me? So look at this. Root 3. It becomes 1 over 3. Because this is 3 over 1. It becomes 1 over 3. So if I have something like root 7, yes, it means a to the power 1 over 7. If I have, let's say, 25 root 3 over 5, this is a root. 3 root of 25. This means 25 raised to the power. Then I reciprocate. This one has a denominator already, so 5 over 3. Take note. So whenever you see that, you do so. When you see this one, you can reverse to that. Thank you. Why? Let's confirm that it is true. Let's confirm that it's true. The calculator will tell you that it's true. So let's confirm it. Let's use our calculator to confirm that. So let's say, which one did you do first? Okay, so let's use this one as example. Cube root of 27. So cube root. You know how to pick cube root on your calculator? Do you see cube root there on top of the root sign here? Do you see it here? That's it. So you press shift and press the root sign, it comes. And you can change it at any time. Just move your cursor there. So if it is 5, you move it. I'll do another one for you to see. 27. The answer is what? 3. The answer is 3. Now let me put it in the calculator and see if the answer is also 3. So 27 raised to the power, and this one raised power box. Take note. Raised to the power what? Box. Then you pick it. Raised to the power 1/2 or 1/3. Sorry, 1/3. And it's a fraction. So I open fraction. 1 forward arrow 3. What is the answer? The answer is also 3. So that's what it means. It's true. Now I want to type in this. The third 3/5 root of 25. Let me write it here. 3/5 root 25. How do I get it? Right? I just type the cube root sign. So shift root sign. Then I use my arrow to go here, clear it, and put fraction key there. It's fraction. 3. Forward arrow 5. Forward arrow. Forward arrow. It brings me inside. What is the number? 25. I put 25. This is what it gives me. SD. This is the answer. So this is how you put cube root. So don't put it this way. 3 root. It is 3 times the root number. Maybe 3 times root 8. That's what it means. The phone root 3, you pick the root 3, make the changes if the number is different from 3. Very important. If it's fraction, put fraction key. So be using your arrow. Alright, so let's move on. So these are the basic laws. Addition, add their multiplication, add their powers, I've explained. Division, subtract their powers. Multiplication or bracket means multiplication, so multiply the powers. Then root, reciprocate the root number and make it power is the same. Good. So if you want the reverse, you repeat. Just come back to the same thing. Okay. Now we are looking at the properties or characteristics of indices. They have behaviors. Any non-zero term, if the number is not 0, that term raised to the power 1 is the same number. So 5 power 1 is 5. What does it mean? 5 once. Is it not 5? 10 power 1 is 10. Why? 10 once. X power 1. So every number is power 1. Right? So x, sorry. Every number is power 1. So if I write 2x plus 3 all into bracket power 1 is the same as this, the same as that number. So every number is power 1 as every number is over 1. So take note. That's the rationale behind it. So simple. So we know it already. So except 0. 0 power 1 is still 0. 0 power 1 is what? Also 0. Are you getting me? So that's you can sorry. It's supposed to be at the other term. Any 0 term, any non-zero. This so you can see that it's typo. This is supposed to be fixed here and it went there. So sorry for that. So 0 power 1 is what? 0. That's it. Now any non-zero term raised to the power 0 is 1. 5 power 0 is 1. 2 power 0 is 1. Why? This 1 power 0 is what? Single 1. Why? We are using the inverse property. Do you remember the inverse property? Sorry, the second property or second law. The second law says that, right? Let's say 2 power 4 divided by 2 power 4. You said division, subtract the power, so it becomes 2 power 4